Welcome to the latest edition of the Mind Gut Conversation podcast, a place to learn about groundbreaking ideas from thought leaders in the area of health, food, the science of mind-body interactions, and the environment. Today, I have the great pleasure to speak to Dr. Martin Blaser, a pioneer and global thought leader in the area of the gut microbiome. Let me just mention a few of Dr. Blaser's amazing accomplishments. He holds the Henry Rutgers Chair of the Human Microbiome at Rutgers University and serves as director of the Center for Advanced Biotechnology and Medicine. He previously served as chair of the Department of Medicine at New York University. A physician and microbiologist, Dr. Blaser has been studying the relationship we have with the human microbiome, the trillions of bacteria that live in us. Over the last 20 years, he has also been actively studying the relationship of the human microbiome with both health and important diseases, including asthma, obesity, diabetes, and cancer. Dr. Blaser has served as president of the Infectious Diseases Society of America, chair of the board of scientific counselors of the National Cancer Institute, and chair of the advisory board for clinical research of the NIH. He currently serves as chair of the Presidential Advisory Council for Combating Antibiotic-Resistant Bacteria. He was elected to the National Academy of Medicine and the American Academy for Arts and Sciences, and has received numerous awards for his scientific work, including the Alexander Fleming Award and the Robert Koch Gold Medal. Last but not least, Dr. Blaser has published over 650 original scientific articles, holds 24 US patents, and is the author of the best-selling book, Missing Microbes, a book targeted to general audiences now translated into 20 languages. Together with his wife, Gloria Dominguez, he stars in the new award-winning documentary, The Silent Extinction. Welcome to the show, Marty. So it's a pleasure to talk to you, Marty. Because of COVID, we haven't really been able to do this in person, but this is a great opportunity to get your opinion on a large number of important topics. And let me just start out with your book, the Missing Microbes, which has really had a major impact on, I think, on the lay public in understanding the implications of some lifestyle changes, and particularly the inappropriate use of antibiotics. If you had to identify one or two things that has happened since the publication of your book that have really shaped the microbiome field, which ones would those be?
Yeah, that's a good question. I started thinking about the concept of missing microbes around the year 2000, and I actually wrote it in 2012, and it was published in 2014. So that's now 9 years ago. And a lot of things. The progress of science is like, it's slow. It's like a wave, and then there's like a little peak, etc. And I think one of the things that is most confirming is that there's been a lot of confirmation of the ideas in missing microbes since then, for both studies in people and studies in experimental models. And really, there are two big ideas in missing microbes. The first is that we've lost a lot of our diversity, and the second is that it's causing diseases. And in these 9 years, there's been a lot of evidence for both of these, that these really are true phenomena. When I started thinking about it around 2000, it was just like, pie in the sky. But it seems to be a true story. But there have been advances. Maybe one of the advances is in the microbiome field, how people are beginning to harness the microbiome to affect therapies, like especially for cancer treatments, for example. This is really an important area of research.
Yeah, and I mean, you've also, I should mention this, we could probably come back to this later. You just came out, with your wife, a really amazing documentary film. What points did you highlight in your film? Or what points did the directors highlight in the film?
Yeah, well, the film is called The Invisible Extinction, and it was made by Steve Lawrence and Sarah Schenk. They're independent filmmakers. They approached, right after Missing Microbes was published, they approached me and said, we'd like to make a film about this. And we have been working with them for the last 8 years.
Oh
And
my God.
in part because it's an independent film, they're always trying to raise money, but eventually they finished it. It premiered last year in Copenhagen and now just premiered in Los Angeles and in New York. So it's coming along. And, the title kind of says it a lot, The Invisible Extinction. It's like the continuation of Missing Microbes. And this film, in addition to laying out the problem and the story, also talks about solutions, ways that people can try to help themselves, in ways that people are helping themselves, and a very big, important global solution, the launching of the microbiota vault, which a project led by Gloria, to save the microbes and store them for future generations, just like the seed vault.
Yeah, so to anybody who has not seen that film, I would highly recommend it. I've seen it myself actually a couple of times, and could relate particularly to some of the scenes in the jungle of Venezuela, at the Yanomami indigenous people. But I would highly recommend it to anybody who's interested in the microbiome field and in their own health, really, because it has an implication for a lot of people. A lot of people with small children or plan to get pregnant. And the bad thing is it's not visible, this extinction. And I think, that's why it probably doesn't get enough attention as you would think it should have with these major impacts.
It's like seeing climate change 50 years ago.
Yeah.
That there are some people who saw it, who knew about it. They talked about the greenhouse effect in those days, but it wasn't in the vocabulary. It wasn't in the contemporary culture, and as a result, it got worse and worse before people began to wake up. And in some ways, this is analogous, and that's why we're crusading to let people know about this, because we're digging ourselves into a hole, and it's getting deeper and deeper. And the sooner we start to stop the damage and fill in the hole, the better the long-term outcomes are going to be.
Yeah, so we'll probably, if you have time, come back to to some aspects of the film. I want to address this topic that you have covered in for a long time in many different ways, this phenomenon of extinction of micro and I would say macroorganisms on the planet. And so a lot of people don't make that connection to say, oh yeah, our microbes, as long as I take my pills for my chronic diseases and I live till 90 years old, I'm happy. But this is an interesting phenomenon that we see this both on a macroscopic scale in really unanticipated proportions and on a microscopic one. I was wondering, why do you think, what's the mechanism that underlies that these trends are happening at the same time? Is there a shared mechanism, or is it just coincidence?
No, I don't think it's coincidence. I think there are shared mechanisms. I mean, one of the points is that we live in a microbial world. Bacteria are the center of the biosphere all over the world. And whether you're talking about in humans or in animals or in plants, the oceans, bacteria have been here the longest. They're the most numerous. They weigh more than all the forms of life on Earth, even all the microscopic bacteria, if you put them on a scale together. They weigh more than all the plants and animals. So we live in a bacterial world, and people noticed the extinctions of visible plants and animals first. Some of that may be due to changes in their microbiome because of the effects of modern life, including climate change and fertilizers and many other things. And then, of course, now we have this extinction within us, this microbial extinction within us that we now know. And I think all of them are driven by the fact that human activities have just increased in scale, compared to a century ago. We're doing things, we're chopping down the rainforest, and we're fertilizing, millions of acres of fields, and we're populating the planet with cows, and the list goes on, and tremendous fertilizers and phosphates, what we're doing to the soil, many of them for good reasons. We're trying to feed people, but people aren't looking at the consequences. So just as I think we have a deficit of bacteria in the human body, we have a deficit of bacteria in the soil and agricultural areas. We're depleting it. We're depleting our aquifers in many places, as well known. So we're living at a rapacious pace right now. And so it's not surprising that it has manifestations in a few different directions.
Yeah, so I mean, I like this term mismatch, the mismatch of the model that I would say particularly, Western people have had in their minds to, how they should interact with the planet, to subdue it and to extract as much as they can without thinking about consequences or impacts on other life forms or in the networks of life on the planet. It's the mismatch of that's stored in our brain, really, and that we transmit in our in our children, and the reality, which is something totally different, which acts according to totally different principles, to networks and systems, and so I think that clash of those two concepts is really what we're seeing, and probably the only hope that we have is that we can change these preconceptions that we carry around with us, and really fundamentally change our interactions with the planet. Do you?
Just to further your point, for most of human existence, we lived on a scale so that the forces of nature completely dominated. And we were just specks. Nature did things, and the world seemed infinite and inexhaustible. And now, in the last century, our human activities have increased so much. So everywhere you go, there are plastics. You see them in the ocean, and waters that were once pristine no longer are, and the list goes on and on. Our human activities have really shown that the Earth is not inexhaustible, and we're stressing it in many places.
Yeah, let me go from that. I mean, I personally find it a fascinating theme, and I never thought when I became a gastroenterologist that this would become one of my main areas of interest. But I think a lot of people still see it in different ways, probably the majority of people. But if we ask ourselves, when did this change? You made this connection to the epidemic of non-communicable diseases, chronic diseases that we've seen, or that we're seeing, and it appears that the microbial world, the gut microbiome, has a lot to do with that, with any of those diseases. In general, I've always assumed this is a trend that has really happened over the last 75 years, since the end of World War II, industrialization of agriculture and other things. But do you think this has been going on for longer, this extinction, this road towards extinction, or is this really that has unfolded in the last 75 years?
I think it's gone on for longer, but it has clearly accelerated during the 75 years. I think maybe you and I met because we were both interested in the bacteria that lives in the human stomach, Helicobacter.
Mm.
And Helicobacter has been one of my great teachers, as I've been studying Helicobacter for the last almost 40 years now. We've learned a lot of things, and I want to point something out that many people don't know, many doctors don't know, and that is that if we consider diseases that involve the stomach, let me go back a step and say that the evidence is pretty clear that Helicobacter pylori is an ancient organism, that it has been around in the human stomach since before we were humans. It really goes back a long way. And one of the consequences of having Helicobacter pylori is that some people get stomach cancer as a result of that. And stomach cancer also is an ancient disease. Hippocrates described stomach cancer. And it's a disease mostly of the elderly. It's kind of the aging in general. It's the aging of the stomach, and that has a consequence. And some people, they die from stomach cancer from Helicobacter. So stomach cancer has been recognized all along. But in the 19th century, a new disease was recognized, and that was ulcers of the stomach, gastric ulcers. It was first found in young women. And there was like an epidemic in England, US, Northern Europe for about 50 years. Stomach ulcers, young women would bleed to death from their ulcers. This was a new disease. It just hadn't been in the medical literature, and it was dramatic enough that it wouldn't have been missed. So this was new, and then that one faded, and then duodenal ulcer disease arose, and it arose. It reached its peak in the birth cohort that was born in the 1870s and 1880s, basically appearing in the early 20th century when people became adults, and then that started to go down, and gastric cancer started to go down, and we now know that was because of the loss of Helicobacter pylori. That those are diseases that where Helicobacter is causing them, and as Helicobacter started to disappear, those diseases started to disappear too. And for me, the kind of the breakthrough happened in the 1990s when I realized that Helicobacter was ancient and it was disappearing. And that's what kind of fueled all my thinking. That's what led to the missing microbes hypothesis. I thought, well, if one organism is missing, probably others have started to disappear too. And that has turned out to be correct. And then a new disease arose in the 1930s. It was reflux esophagitis, or esophageal reflux, or GERD, or GORD, however you call it. That was a new disease also. Hadn't been found before, hadn't been described before. And as you know, as a gastroenterologist, that's just zoomed up since then. Mm-hmm. And that is pretty clearly due to that Helicobacter is protective against that disease. So as Helicobacter has been disappearing, the diseases it's associated with are disappearing, and now new diseases are appearing, and that GERD can lead to a new form of cancer, and there's a new form of stomach cancer that has been found. So it's kind of a dynamic world, but things began in the 19th century, and we can use kind of Helicobacter as the canary in the coal mine. That's as the indicator. In the early 20th century, we began to chlorinate our water. And I think that as marvelous a thing as that is for public health, I think it had unforeseen consequences.
But in the case of Helicobacter, if you play the devil's advocate, you could say that wasn't such a good thing that it disappeared. So it was not a good thing that we got rid of it, because, yeah, on the one side, it protected against these ancient stomach cancer diseases, but it created a whole range of new diseases that so the net effect may be, may
We
not
don't
be.
know. Right. Well, it isn't over yet. By the way, also the children who don't have Helicobacter are at higher risk for asthma, also asthma and allergies. So in 1998, 25 years ago, I wrote in the British Medical Journal that we'll be giving Helicobacter pylori back to children. So that, along the lines that you're suggesting, because in that, there has been a trade-off. We've lost some diseases, but we've gained others. And the story isn't over. We don't know which is better. One of my ideas is that we've had Helicobacter for so long, and by and large, it's pretty benign. 90, 95 people out of 100 don't have any consequence. And there's an old saying that nature abhors a vacuum. And so when Helicobacter disappears, it creates a niche. It was the dominant organism of the human stomach. I'm not sure that the next Helicobacter is going to be as benign for us as this one has been in net. So if you only focus on one piece, Helicobacter can look awful, or it can look wonderful, but you have to look at the whole picture.
Yeah, that's always the thing. Yeah. I mean, one point that I always throw in these discussions, even though nobody is really interested in that anymore. So when I came in my training, to work with John Walsh at UCLA, obviously that research institute was all focused on factors underlying the peptic ulcer epidemic, and I personally always pursued this avenue that chronic stress does play an important role. And now today we know this interaction of the sympathetic nervous system with the microbes actually can change their behavior. So increased gene expression, virulence of many microorganisms, norepinephrine leaking into the gut and then interacting with, adrenergic-like receptors. So that part of the story was completely, abandoned and forgotten. So now I think we have a situation after war was declared on Helicobacter in general. At the end, we may come out with something that we never expected, like often in medicine. That
yeah, I've been blowing that horn for the last 25 years, and as you know, most physicians, most gastroenterologists still think the only good Helicobacter is a dead one.
Yeah.
That's the practice of medicine today, and I think it's very short-sighted.
Yeah. Let me ask you another question in terms of extinction. So this is two things that one could one explanation is that one could use for if you can't measure something with our currently available techniques in the microbiome. You could either say it's extinct or it's below the detection threshold of our techniques. And I was kind of, and there may be many explanations, I'd like to hear yours. In this recent study by the Sonnenbergs, where they compared a probiotic-rich diet or fermented food-rich diet with a high-fiber diet, that actually the fermented food diet had a greater impact on the diversity of the microbiome. And the most interesting part of the story was that it was not due to the microbes in the fermented food, lactobacilli and bifidobacteria, but other microbes appeared all of a sudden in that setting. Is this something that could explain some of the, to explain some of the extinction that we've been seeing, or do you think? So when you say extinct, you think it's really gone, just like animals that are,
Yeah. So, I mean, I think that there's a lot of evidence for extinction, unfortunately, where Helicobacter, again, is a very good example. We can tell whether somebody has it or they don't have it. We can tell it many different ways. It's But there also is the possibility that certain organisms, you see, the thing that I like to remind people about is that microbes are small, and they're really small. And in our body, we have certain microbes, that we have 100 billion of them or more. And we have some that we have 1 billion, and some that we have 1 million, and maybe some that we have 1,000. There's a whole range. That's true in many ecological systems. It's not just true in the human body, that there's a big difference in the abundances that we have. And one of my theories about antibiotics is that, when you take an antibiotic, you suppress many different organisms, and the numbers go down. Now, if you started with 100 billion, when the antibiotic is over, at the end of the day, you're still going to have a lot of bacteria left. But if you only started with 1,000, maybe you won't do that well. And one of the ideas is every time we take an antibiotic, some strain or some species goes extinct. When you change your diet, and now your microbiome changes, is it because the diet has brought in the new organisms, or were they actually there already in a low number, and now they have bloomed to reach a level that can be detected? And I think we can study that experimentally, let's say with germ-free mice, and we colonize them. But in real world studies, it's a little hard to tell the difference. But it's certainly possible that you see in the gut, we can just say there are good guys and bad guys, and sometimes you have an organism that's a bully. It's dominating everybody else, and it's suppressing everybody else. And now you change something, you bring in its enemy, and now the other guys can flourish. Not because it was present in the yogurt, but because the organisms in the yogurt suppress the bully.
Oh, okay. But that's an interesting explanation. That another point, I mean, each of these topics we could go on for a long time, but I want to cover sort of a wide range of issues that I personally find very interesting. And I know you're one of the few people who can really give the most authoritative answers to. Coming back to these microbiome change, the association of gut microbiome changes and the increase of chronic diseases. There's obviously multiple mechanisms of how this could come about, and so there's, I would say, really two major categories. One is that it would be related to the systemic immune activation that's triggered by the diet and the change in microbes, and then the change in the gut barrier, and activation of the gut-based immune system. But it could also be because these microbes produce these specific metabolites. Some of them neuroactive, some of them have been involved in many disease processes, like kynurenine, a tryptophan metabolite. Or do you think it's a combination of both? This is one of the few areas in my career where I felt that it's sort of like the string theory of chronic disease. It's the inflammation, So a lot of lay media share that kind of idea. As a scientist, you're always skeptical when something like this happens. So what do you think? Do you think the low-grade inflammation throughout the body, or metabolic endotoxemia, is really the main factor that links the diet, the microbiome changes, and with these chronic diseases?
Well, as you said, we could discuss this for a long time, really a long time. I actually try not to use the word inflammation. I try to use it as little as possible. It's kind of like if I said to you, well, now I'm breathing, and now I'm breathing. I'm breathing all the time. So the thing is that our body has an immune system, and it has many different components and arms, and it is active all the time. It's just like breathing. It's there all the time. And a big part of it is to interact with our microbiome. I mean, it's there every moment. And so really the question is, where are the set points? Where are the thresholds? And how does the interaction between the immune system and the microbiome affect it, when you see an allergen, for example, when a cockroach walks across your skin, everybody's going to get allergic, but can you turn off that allergen or not, that allergic response or not? And so that's an example. And again, all of this could affect the brain in many different ways, through metabolites, through hard wiring as well. So I try not to use the word inflammation for that reason.
Yeah, I mean, that to me also, I mean, inflammation, from medical school on, inflammation is involved with white cell, increased white cells and infection. And
yes, and in some cases, it's a very useful term, when somebody has, an abscess, they have, they have a wound, it's gotten infected, there's pus everywhere. I mean, that's a very acute inflammatory situation that we all know, we all recognize. But the kinds of things we're talking about are much more subtle. They're really about thresholds and set points, the relationship between activation and suppression. The immune system is a two-edged sword. Sometimes it activates, sometimes it represses. And health is kind of when they're in the proper balance, whatever that might be.
Yeah, so I mean, staying with this point, so let's say this inappropriate engagement of the immune system, just by increasing the thinning the mucus layer of the gut, basically breaking down the barrier, compromising the barrier. But the microbial world has its own sort of, I always call it the aspirin of the microbial world, the short chain fatty acids, butyrate, which have these beneficial effects and anti-inflammatory effects on locations from the gut epithelium to immune cells and all the way up to the brain. So there's almost like this yin and yang. If there's an engagement of the immune system, the microbes will also produce substances that will suppress or contain it. And it's the balance between those two that really determines if it's pathological, or if it would. I mean, would you agree with that?
Yeah, I'm very focused on early life. I'm focused on how things develop. We know, even before the microbiome was discovered, we know that babies go through a kind of developmental cascade. They get bigger, their brains get bigger, they have more functions. Early life is the critical time when things are developing. And of course, it's when the microbiome is developing also. So I think that in modern life, because of antibiotics and other factors and C-sections, et cetera, we have changed the balance between the microbiome and the development of immunity and metabolism and cognition. And they're all intermixed. They're not isolated. The hormones and the T cells, and the nervous system, they're all talking together. So let's see. So what you might find particularly interesting is a study that we did a couple of years ago with colleagues at the Mayo Clinic. The Mayo Clinic is located in Olmsted County, Minnesota. And there have been many studies that have been done of populations in Olmsted County, because it's a very stable population. They have very good medical records, and almost everybody gets their medical care from the Mayo Clinic. So I visited there a few years ago at the Mayo Clinic, and I thought, why don't we do a study of antibiotics in the kids from Olmsted County? And my colleagues at the Mayo Clinic agreed. And so a pretty big study was done. We studied all the children born in Olmsted County over a several-year period. Turned out we studied about 14,000 children. And we basically asked three questions. First, what was their antibiotic exposure early in life? Second, what kind of health conditions did they have when they were a little older? And third, were the two things related? So we found that about 70% of kids received antibiotics in the first 2 years of life. They got the common antibiotics that kids mostly get. Some of them got multiple courses of antibiotics. 30% didn't get any. And then we found that between the age, and we looked at antibiotics up to the age of 2. And then we looked at health conditions after the age of 2, from 2 to 14. And we studied 10 different health conditions. Common health conditions in childhood: asthma, hay fever, eczema, dermatitis, food allergies, celiac disease, obesity, overweight, ADHD, autism, learning disabilities. This study was unusual because we looked at all 10 conditions at the same time. And then we did a statistical analysis. And in this kind of analysis, we construct something called a hazard ratio. So a hazard ratio of 1 says that antibiotics are neutral. There's no relationship with the subsequent disease. But in this case, we found that all 10 conditions had hazard ratios greater than 1. And 8 of the 10 were statistically significant. There was a significant association. And we also found that the number of antibiotic courses mattered. The more courses, the greater the disease. The timing of the antibiotics mattered. For some diseases, the first 6 months of life was really important, and others, it was the next year of life. And also some antibiotics were worse than others. So this was really a remarkable finding. And since then, I've done studies with colleagues looking at a population in England, a population of more than 1 million children. And actually, we've confirmed almost all the findings. We presented this at a meeting, and we're just working on the manuscript now.
That's amazing and shocking at the same time. I mean, if most people, what they think about, they get an upset stomach or diarrhea after an antibiotic course, but I think few people, particularly parents of small children, that kind of twist the arm of their family practitioner to give them an antibiotic for the bad cough or respiratory infection. They're not really aware of this. And what do you think is the solution? I mean, antibiotics are essential. They are an essential tool in medicine. What do you think the solution is to deal with this collateral damage?
Yeah. I mean, that's really the big question. And we've kind of been digging this hole for the last 75 years since antibiotics have come in the scene. And I can give you an example. There's a very common condition in children, ear infections, otitis media, and we know that most of those are caused by viruses. They're not caused by bacteria, but many kids end up leaving the doctor's office with an antibiotic. So we can think of a spectrum. I think that there are some kids who have really terrible ear infections, and those kids must get antibiotics. We can say that's the black end of the spectrum. And at the other end, there are kids who have very mild, they have sniffles, they're not very sick at all. They should never get antibiotics. We can call that the white end of the spectrum. And in between, there's a big gray area in the spectrum. And different doctors are cutting that gray at different points. In Sweden, they're using 40% of the antibiotics that we're using. So they're cutting it way down on the white side. And even in US practices, there's tremendous variation in doctors. So one of the things is try to move people, doctors, more to that white side of the spectrum, and move the expectation of parents that most of these conditions don't need antibiotics. So it takes a big educational campaign. It's one of the reasons that I was happy to work with the filmmakers to make Invisible Extinction, so that we can talk to the public directly.
Mm-hmm. Yeah, so in our previous conversations, you also mentioned another strategy to develop different types of antibiotics that are selective for a particular organism. It don't cause this white collateral damage on other organisms. How far along is that field of research and development?
Well, the idea is gaining ground, and the idea is instead of most of the antibiotics we're using today are broad spectrum antibiotics that have a lot of effect. When you take one, it's affecting all the microbes in your body. But you're only infected, let's say, with one bacteria. You only have strep, or you only have E. coli. So we need to develop narrow spectrum antibiotics, what we might call strepsilin or E. coli-silin or something like that, that will only just focus in like a laser on those bugs. I think the technology is there to do it. The problem is that there's no market for it. The idea, because the current broad spectrum antibiotics are very inexpensive. Why would a health system pay $300 for a course of antibiotics when they can do it for $5? So but I think that we need to develop it as a matter of national policy. Our country and other developed countries, it's like none of us can afford to build an interstate highway ourselves. We use our tax dollars because that's a public good. We're all benefiting from it. We need to develop narrow spectrum antibiotics, and we need to develop the diagnostics so that we say, okay, this child has a strep infection and this child has a viral infection. They don't need anything. And if they have this strep infection, then we have to create strepsilin and take it off the shelf and use it. And it won't have collateral damage.
What do you think? I mean, this is not directly related, but I just want to hear your opinion on this. So there is a strategy in an area that, I've been working on for a long time in irritable bowel syndrome to give an antibiotic as a treatment, presumably targeted at small bowel intestinal overgrowth, which is a questionable entity, really highly questionable. And the whole cottage industry has been built around that topic. And so this is obviously the worst thing that you can do today. I mean, to give to relatively healthy people. And there are attempts to move the age limit down, get approval by the by the FDA to also treat young patients with this. Isn't this kind of an amazing development that runs counter to all of our insights and all the things we've talked about?
Yeah, I think you have hit the nail on the head. It's a terrible idea. And part of it is that there are many things about the human body that we don't understand. And there's kind of an instinct to throw an antibiotic at it. And, so this kind of, as you say, this small bowel overgrowth, or SBO, is a fairly vague diagnosis. There are tests that can detect it, but those tests have a questionable basis themselves. And there are companies that selling drugs that are useful for that, for the real cases of that. But it's that diagnosis has blossomed, kind of out of proportion. So I think this is mostly a medical fiction, and of course, giving more antibiotics is moving in exactly the wrong direction. I think a doctor actually suggested it for my daughter who has celiac disease, who we discussed in the film, and I said absolutely not.
Yeah, I'm glad to hear that we're really on the same wavelength of that. Even though the majority of physicians and gastroenterologists have sort of bought on to this idea.
It sounds good. It's very appealing, but when you study it and you ask, okay, so did the people who you treated with antibiotics, did they get better? The answer is no. Sometimes the tests got better, but the people didn't get better. So that means that the tests aren't really measuring what we want to measure, what we need to measure.
So yeah, let's end this conversation with a couple of sort of more general questions, asking your personal opinion. So looking into the future, do you believe that humans will dramatically change their lifestyle that they have switched to in the last 75 years, and their interactions with the environment, which is part of that, to prevent catastrophic consequences, as you pointed out, many years ago in your book, Missing Microbes, like the antibiotic winter and others. Do you think humans will make that change in the next, I don't know how much time we have, 10 years, 20 years?
Yeah. Well, I wanted to call my book Antibiotic Winter, but the publisher thought it was too scary. And so Antibiotic Winter is chapter 15 in the book. And it is the scariest part, because what I was worried when I wrote this in 2012, what I was worried about was a pandemic that that would just spread around the world. Of course, we've now just seen such a pandemic. And as bad as COVID has been, there have been worse pandemics. And there is the potential for a worse pandemic. And part of the problem is that our microbiome is our Coast Guard. It's our first line of defense against invading organisms, and we've been depleting it. So, as bad as obesity is, and asthma and allergies, pandemic is the thing that's really scary. That's the thing that keeps me awake at night. And so we have to figure out, how can we replenish our microbiome? How can we get it back to a more ancestral state, so that as a population we have more resistance to invaders? That's the big worry.
I mean, if you look at how slow things are moving, for example, with climate change, there's these annual conferences and pledges being made, and then not much really. The needle doesn't really move that much. It's more. So, do you see enough changes worldwide in the inappropriate use and excessive use of antibiotics, C-section deliveries, and diet, encroachment of wild habitats, that suggests we will be able to dodge the bullet?
Yeah, it's not black or white. It's not yes or no. I'm hoping that we can turn the ship around. It's got a lot of momentum. It's got a lot of inertia. We want to turn it around gradually. I was going to say something, and now the whole thought has flown away.
I know that phenomenon.
I had such a good thought to tell you, but
yeah, maybe we can come back to this.
Oh, I know what it is. I know what it is. You see, the problem, I think that one of the really biggest problems is that we fell in love with antibiotics. Antibiotics came on the scene. They were so miraculous that the medical profession, the public, it's a pillar of our civilization that antibiotics are good for us. And as a result, we've been using them more and more and more for increasingly marginal uses. And it's because of the idea is this might not help you, but it won't hurt. But as studies like the one we did with the scientists at Mayo Clinic are showing, and I'll tell you about a couple of other studies in a moment, maybe every time we take an antibiotic, there's some cost to us. And when you summate it all, then it means that we have to change the practice, because we have been overestimating the benefits and underestimating the costs. And we need more transparency. And I'm hoping that parents, instead of saying, give my child an antibiotic, they'll go to the doctor or health practitioner and they'll say, please examine my child carefully and let us know what we need to do. Will the child need an antibiotic, or are they better off without? I'd like to change the conversation. And I think as people understand that antibiotics have consequences, that they have cost, long-term cost, I think we're going to be turning that boat around. What I wanted to mention to you is I've been mostly focused on kids, but there are now a number of big epidemiologic studies of adults. There are two studies in Europe, one in England and one in Denmark, each one a study of more than 1 million people, that looked at the relationship between prior antibiotics and the diagnosis of diabetes. And both studies showed that the people who have diabetes today had more courses of antibiotics in the preceding 15 years than the people who didn't. even years earlier. So it's not falsely related to diabetes. It really preceded by years. Both of these studies showed the same thing, big scale.
And this is type 2, it's type 2
This
diabetes.
is type 2 diabetes, adult onset diabetes. There have now also been 2 studies of kidney stones showing that people who have kidney stones had higher exposure to antibiotics in the years preceding. Now, we know that kidney stones are a metabolic disease. We know that microbiome has something to do with metabolism. And so this kind of thing is plausible. And the incidence of kidney stones keeps rising. In the United States, about 1 person in 10 is now going to get a kidney stone in their lifetime. So, when did a doctor ever tell you that if you took an antibiotic, it might increase your chance for kidney stone, that it might increase your chance for diabetes? That's not in the conversation, but I'm predicting that it will be, because the data keep coming out. There was also a very good study. You're familiar with the nurses study, which has been going on for decades now, where more than 100,000 nurses were enrolled in studies looking at their behaviors, their exposures, and their health outcomes. Well, recently there was a paper of 16,000 participants in the nurses study who had colonoscopy after the age of 60. And of those 16,000, about 1,300 had polyps, which is the pre-malignant lesion in the colon. And so the investigators who they have all the records from the nurse study, they say in the 20-year period between the age of 40 and 60, which group had more antibiotics, those who had the polyps or those who didn't? And the answer is those who had the polyps had more antibiotics in the 20-year period, and it was statistically significant. And then they said, how about in the 40 years before, between the age of 20 and 40? What was the antibiotic use in them? And the women who had the polyps, they had more antibiotics also. All of these point to the idea that antibiotics have cost, and they have cost for diseases that are rising. You know that colon cancer, there's a big rise in colon cancer in young people.
Yeah.
So this wasn't on the radar before, but part of our job is to put it on the radar.
Yeah, and it's amazing, particularly this example with colon cancer in younger populations. So the response of the medical system has been to lower the threshold for the screening colonoscopies, which is obviously not the answer to this problem. If antibiotics early in life play such a role, then there should be more pressure in that area rather than to find them earlier.
I don't think they're not exclusive. You don't have to choose one or the other. I think early screening makes sense when you have rising disease, but we have to get to the root cause of it.
Yeah. So let me ask you one last question. I think I know the answer after our conversation. If there is one intervention that you think will have the biggest impact on our current chronic healthcare epidemic, which one do you think that will be?
I think I'll pick 2. I'll pick 2. One is that we have to decrease our exposure to broad spectrum antibiotics. That means fewer antibiotics and the development of narrow spectrum, so that we can decrease the damage, so that whatever is done in our population, but we don't keep damaging it generation after generation, because there's evidence that it crosses generations as well. Mm-hmm. And the other thing is, I think that we need to start to restore. We have to understand the microbes that are really important early in life, and then I'm predicting that we're going to be giving these microbes back to children, to bring them back, the kind of the critical, the keystone microbes, to bring them back to their ancestral state, that state that we have lost. I don't know if it's going to happen in my lifetime or your lifetime, but I'm thinking that it's going to happen, over the next few decades, that we're going to understand what are the critical organisms, and then just like we give kids vaccines to protect them against polio and tetanus, et cetera, they're going to drink some organisms, and that's going to restore their microbiome. I think that's what's going to happen.
Since you were correct with many of the predictions, and concepts that you wrote in your book, The Missing Microbes, more than a decade ago. I would imagine, I would trust your predictions of what's going to help us to get out of this hole. So I'd like to thank you for this wonderful conversation. Also, I want to remind our listeners, we mentioned this a few times, if you haven't read the book, The Missing Microbe, please do it. It's still as accurate and topical as it was when it first came out. And don't miss an opportunity to watch on Amazon Prime the movie The Invisible Extinction, a really eye-opening documentary that addresses many of the topics that we talked about today in practical examples. So if you have an opportunity to look at it tonight, you will not regret it.
Thanks so much, Emran. It's always a pleasure to talk to you. And I remember that you went to work with the Yanomami decades ago. So you were ahead of your time too. So
thanks, Marty. And thanks for the conversation.
Yeah,
Bye-bye.
nice to talk to you. Bye-bye.